How's it going, everybody? Mr. D here. In this video, we're going to carry on the previous videos discussion about quadratic models. We will be using our graphing calculators a little bit today, so make sure you have those ready to go. And then we're also going to be doing just a few kind of review type questions as well. So just to get you ready for the recap of the 3A unit. Hard to believe that we're almost already entirely done with this unit, but here we are. So without further ado, let us begin. First, we have a problem in which we are asked to find the c value, aka the y-intercept, of a function given nothing other than its vertex. Now, if we think about what we know about the vertex, we know that, okay, if I did x equals the opposite of b over 2a, that'll at least spit out the x value, but if I did that, I already know the x value of the vertex. I already have this piece, and I already have the b and the a value, and I'm trying to find the c value here. So that might not give me much guidance. So I probably don't want to use that method. Instead, what I'll try to do is let's just use the fact that the vertex is nothing more than a coordinate that's on our parabola, isn't it? So I could plug in 2 for x and 3 for y, and then solve for c based on that. So if 2 was x and then 3 was y, this is what my equation would look like. I now have one equation with one single unknown value. So this is just straight up algebra 1 skills. Now, simplifying this thing. So negative 2 times, let's see, 2 squared is 4. Negative 2 times 4 is negative 8. Plus 8 times 2, that'd be 16 plus c. So 3 equals, this would be 8 plus c. Therefore, c is negative 5. Yay. And then next says, how many x-intercepts will it have? And this is one where if you just kind of visualize it, it's going to be a lot easier. Yes, we could do some reverse engineering with some math properties, and we could really discuss like the exact number and if there were x-intercepts, what the exact number would be. Or we could come to the conclusion that, depending on our graph, your parabola could have maybe 2 x-intercepts. Maybe the vertex is on the x-axis, or maybe it doesn't have any x-intercepts at all. So if I take what I know about this parabola in particular, I know that it opens downward because my a value is negative, and they told me my vertex is 2, 3, so my vertex would be somewhere in that first quadrant. So if it opens down with the vertex above the x-axis, well, then we're going to have at least exactly 2 x-intercepts. All right, onward we go. So carrying on what we talked about in the previous lesson, we want to use our calculators to be able to come up with a quadratic regression based on a table of information. So here we have predicted temperatures in Sacramento, California, where x is going to be our time, and our y values is going to be the temperature. Now, some of you might be noticing something that could throw off our calculator, and that is right here. As soon as we hit the PM times, the way we tell time, those numbers reset. As soon as you get past noon, you start over at 1 o'clock, 2 o'clock, 3 o'clock, so on and so on. Our calculator doesn't know that. Our calculator isn't very smart. It doesn't understand that. So what we have to do is convert this to 24-hour time. So when you're doing that, you're essentially taking any PM value and adding 12 to it. So 2 PM is really going to be 14. 4 PM would be 16, 6 PM would be 18. So these are going to be the numbers that we have to use when we go to our calculator. And again, the reason for that is our calculator can't distinguish. It doesn't know the difference between a 3 a.m. and a 3 p.m. It does know the difference between a 3 and a 15. So let's go to our calculator. Let's get the model. All right, stat menu, edit. I'm just going to type over these things. So we have 8, 10, 12, 14, 16, and 18. And over here, 52, 64, 72, 78, 81, and 76. Oh boy, 76. All right, so then we go stat, over to calc. Quad reg is going to be option 5. We'll go down to calculate. And now we're going to start getting some nasty numbers. Now what this means is that these points don't necessarily follow an exact quadratic model. So our calculator is giving us the best approximation it can. Think back to when we did scatter plots with straight lines and we did linear regressions. That line's not going to hit every single point of the scatter plot. It's just going to give you the best approximation possible. That's what our calculator is doing, only now with parabolas. So we're going to take those A, B, and C values, and we are going to throw them in the standard form of an equation. Then it's going to say use the model to predict the high temperature for the day. At what time will the high occur? Well, if I know my function, I can go to my y equals menu and I can plug in all these values. So negative 0.469 x squared plus 14.716 x minus 36.121. Now if I graph it, chances are I won't be able to see it. That's understandable. I'm going to change my x max and my y max. So let's change x max to, well, I know it can't go past 24, right? Because there's 24 hours in a day. And let's say y max, we'll put that at 100. I don't think our temperature is going to get past 100. So now let's see if we can see the whole graph. Cool. We'll go calc. Nope, second calc, my apologies. Option 4 is the maximum. Left bound somewhere clearly to the left of the vertex. Come on now. And we'll scroll over somewhere clearly to the right. And we get 2 points, 15.68 and 79.31. All right. So we want to figure out at what time will the high occur. So 15.68. Let's see, 15.68. Well, 15, that's going to be 3 p.m., right? 1500 hours is 3 p.m. But then 0.68, well, that's 0.68 of 60 minutes. So if I multiply that by 60, that'll actually give me the minutes. So 68% of a 60-minute hour is what that would turn into. So when we do that, hey now, at 3:41, that's when we'll get our high temp of 79.3. Now, some of you might have alarms sounding in your head because clearly we had high temps that were past 79.3, and you'd be right, but keep in mind this is just an approximation. So this quadratic doesn't work for every single point. It's just the best approximation so that we can use that to predict further models. And then it says, use this model to use the equation to predict the temperature at 10 p.m. Well, 10 p.m., if I think of adding 12, because that's a p.m. number, that would have an x value of 22 that I'd have to plug in. So we would plug the value 22 in for x into this equation right here. And after a little bit of rounding, you should get 60.6 degrees. All right, for the next few slides and problems, I'm actually going to just put the problem up there. I'll ask that you pause the video, and then I'll go through and kind of uncover the answers. All right, so first one, we have speed and fuel economy, so gas mileage, represented in a table here. Now this table is really just one long table, right? This whole bottom half should have kind of continued off the edge here, but we just ran out of space, so it got truncated and then thrown down there. So all of these values that are highlighted in yellow, those are going to go in for your X column. All of the unhighlighted ones, those will go in for your Y column, so L1, L2. All right, so I'm going to ask that you guys pause the video here, get that stuff entered, and then go through and try to predict the model. All right. So if all was done correctly, this is the equation you should have had your calculator spit out. And then it's going to say find the speed that maximizes the car's fuel economy. And what was that maximum fuel economy? So essentially for both of these, we're finding the vertex. And the vertex is going to give us two numbers, an X and a Y value. The X value is going to represent the speed, and the Y value is going to represent the fuel economy. So we're finding that maximum, aka the vertex. And these are the values that we should have. Come on now. All right, next problem. This one's going to be very similar to the first problem with the calculator that we did. So here we're comparing time and predicted temperature again. So same thing, make sure you're using the 24-hour time for these guys. So this would be 15, 18, so on and so on. That's a horrendous 18, I'm sorry about that. So that goes in your L1, L2 columns, and then you'll be asked the same thing. What's the equation? What's the maximum? That's going to be the general theme here, folks. So go ahead and pause the video, and then I'll uncover these. Okay, so just another reminder, when you get 2:54 p.m., that's because your calculator, for a maximum, probably spit out 14 point blah, 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 and we had to convert that to regular time from our 24-hour clock. So it would have been 14.9. All right, next one. We have a trajectory. So they're giving us the equation. How fun. If they give us the equation, that's one less thing we have to do. So what's the max? How long does it take to get to the max? So these first two questions are talking about the vertex. So you have two options for the vertex. You can either do our calculator, and you can go option 5 under the calculations menu, or you could do the negative b over 2a and plug that back in. Both methods are totally valid, whatever you want to do. So the vertex here is going to be split apart into two values. The height is going to be the y value, and how long will it take? That's going to be your x value. So if we do that, we'd get a vertex of 2.25 comma 86. And part C is saying how high off the ground was the arrow when it was first shot? Well, that's just asking us for the starting height, which is also the y-intercept. The y-intercept is just our C value. So in this case, it was 5. And double check our units. We're going to be at 5 feet. All right, last one. Here we have an equation. We're talking about profit versus bags of chips. So if you guys want to pause the video so you can get this equation typed into your calculator, that's not a bad idea. Once it's in your calculator, you can find the vertex, or you could do the negative b over 2a, or opposite of b over 2a, whatever. So those are your options, opposite of b over 2a or calculator. Regardless of which method you choose, there's your vertex. And then it's asking for axis of symmetry. Well, the axis of symmetry is nothing more than the x value. And then what does this vertex mean in context of the problem? And what does the starting value mean in context of the problem? There you go. right, that's it. That's all, folks. You know the drill. If you have any questions, let me know. Good luck. Have fun. Be safe. Roll Tide.